Hello, everybody, and welcome to our special webinar today on how to win with over-the-air software updates. My name is Stephen Cawley. I'm the head of enterprise marketing at Northern Tech in Mender, and I'm joined today by Farshad Tavakoli, my colleague in product marketing and product management, who will be presenting today on over-the-air software updates. Some housekeeping before we begin. You can enter your questions into the Q&A box, and we'll do our best to address those questions at the end of the session. I just want to say before I hand over to Farshad that I think you'll spend a good 30 minutes with us today. We're a company that has a very good mission. We're trying to secure the world's connected devices. We can help organizations to focus on their core value propositions and look after their infrastructural needs as a trusted partner. We also want to say, don't go down the road of homegrown systems, building a homegrown system for OTA software updates. Look for a best-of-breed partner like Mender. And remember that Mender is a recognized partner of Microsoft Azure IoT, Google IoT Core, NXP, and several other world-class players within the field of IoT. Our engineers are always close, available to support, responsive, and they're backed up by an open source community of over 700 contributors on the Mender Hub. And remember also, avoid lock-ins. We have an open core model and we are flexible to meet your needs. And with that, let's quickly go through today's lineup. So I'm going to hand over to Farshad. He's going to talk about the urgent need in the market today for a robust system of over-the-air software updates. He's also going to talk about the various industry challenges. He's going to talk about what it takes to actually implement an end-to-end over-the-air software updating solution for IoT gateway devices. And then we'll show some real case studies where Mender is having impact in the industrial world. So with that, I'm going to hand over to my colleague and expert, Farshad.
Thanks, Stephen. Thanks for that introduction. Yes. OTA updates can be seen as a way to become more competitive in today's tough business environments and enable efficient go-to-market strategies for many small to large enterprises. So from the end user perspective, a software update is an enhancement to the current operating system version containing new features and performance improvements, including safety and security features. And from the manufacturer's perspective, a software update is an opportunity to not only reduce costs, but also delight consumers with a continuously better user experience. They can differentiate the OEM from the competition. For example, recently BMW announced that they will use OTA updates to activate features in the cars, such as heated seats, infotainment features, and others, for a monthly subscription fee or annual subscription fee. As software grows in complexity, so does the chance for new bugs and vulnerabilities. The need to do software updates stays imperative throughout the product lifecycle, from the development and maintenance of an IoT product in production to post-production and finally end of life. Updating requirements can be components related to a system or application. System updates can be low-level things such as bootloader, kernel, root file system. These are essentially your OS operating system files. And also from an application layer updates perspective, it could be higher. It's in the higher software stack, which deals with user experience and device functionality, which may require more frequent updates, such as containers, packages, files, and directories. Government bodies around the world have started to mandate security protection measures to be implemented in all internet-connected devices. In this case, in June of 2020, the European Union introduced a new cybersecurity standard for all consumer IoT products. It hopes that the new standard will lead to better security practices and more vendors adopting a secure by design principle or security by design principle when developing new connected consumer products. Similarly, we've seen similar measures in the US in this case by National Institute of Standards and Technology, which recommends organizations implement security controls and ensure their systems are up to date continuously. This includes identifying and correcting information security flaws, installing software patches, and other securities. So we've starting to see government bodies to actually come into play. Now companies wanting to actually pursue this internally find that there are challenges with developing, implementing, and maintaining a homegrown end-to-end solution, and comes at an inherently high cost. They're time-consuming, average 6 months to a year for a mediocre solution. It costs too much. It could be in the hundreds of thousands of dollars for the fully featured end-to-end solution. And they lack in-house competencies. Usually a fast solution, a turnaround, quick solution around these will lead to a mediocre solution that makes the device fragile and vulnerable, at risk of being hacked or bricked. And also it adds complexity to the product development cycle, which could jeopardize the time to market and takes away focus from the company's core competencies to actually what they're trying to develop in the product itself. There's a McKenzie company study in 2019 finds that most IoT ecosystem contributors or leaders prefer outsourcing solutions that is not part of their core competency, as opposed to developing them themselves internally in-house. This tends to bring more efficiency to their organization. But however, when companies trying to look into solutions out there, they'll find some challenges. There are inherently challenges out there. High degree of fragmentation in embedded device hardware and software makes it costly and difficult to make consistent and fully compatible solutions. This fragmentation is mainly from lack of standards and a large number of ecosystem players. You have, component suppliers, SoC vendors, OEMs, and board vendors all play a role in this fragmentation. And then this fragmentation essentially puts the development organization at crossroads regarding the path they should seek for their connected device project. And depending on the product goals and business objectives, things may get even more complex when planning for mass production beyond just piloting and proof of concept. And what solutions are out there besides homegrown, as we discussed in the previous slides, with its challenges? There are the generic public cloud vendors, open source contributors, and other dedicated IoT platforms or solution providers, but they're all locked in. There are lock-in solutions. The platforms and solution providers, they all wish to cater to the whole IoT value chain, tackle these various needs in the market, but none deliver specialized and optimized solutions for doing OTA efficiently, more secure, and risk tolerant. The IoT device environment could be unforgiving. These devices, they are remote, and they can be exposed to unreliable power and network. And there are challenges, and you want to make sure that these devices are safe and secure. And yes, and this brings us to what's needed for a successful OTA update solution. You need an OTA update mechanism needs the ability to manage an entire fleet of connected devices. Many homegrown OTA solutions are restricted to updating the devices one by one, which easily becomes unmanageable and error-prone as the fleet of devices grows in population. Second thing, you want to be able to provide signed images greatly. Signed images greatly enhances the security of your system. Maintaining the private keys separately from your code base and your server infrastructure allows you to decouple these components. This means that even if your server is breached, for example, then attackers will not be able to install new images onto your client devices, as they will not have the appropriate signing keys. It is crucial that the application of the signatures be a separate step from the rest of your build and deploy mechanism to best protect this resource. And then you also want to make sure that software updates are sent to intended devices and provide some sort of hardware compatibility checks. You also want to be able to do all kinds of software where you need to, essentially, as we discussed earlier in this webinar, such as application updates, which has containers, packages, files, directories, as well as being able to do system level, OS level updates to the kernel and root file system. Integrity verification to avoid corrupting updates are crucial, and also you don't want half-done installations, so you want atomic updates. You want full operational and also fail-safe in case of losing power or internet connectivity. So you need to consider all of these steps in order to have a successful end-to-end solution. This is really a little bit more detail into the previous slide that I'll try to cover here. Each of these boxes are a basic functional piece of the server. Some are required and some are optional. Although I would not use a system that only supports the required features, it's not recommended. Starting in the upper left, you need some mechanism to detect an update. This should be over an encrypted channel to allow you to verify that you're connecting to the correct channel. Next, you want to check that the image being installed is actually for the device in question to avoid costly errors. The next several steps are useful to increase the security and reliability of your system. Integrity checks help to protect against corrupted downloads, while authentication and encryption help protect against deliberate attacks. Support for compressed images reduces cost, and we all want that for download, which depending on your device's connectivity may be significant. And then pre and post-install actions are crucial to adopt the update workflow to your application. This can be useful for things like database migration, software sanity checks, and in general, making the system more applicable to your specific use case. The install state is pretty self-explanatory. Sanity checks are used after the installation to make sure that the system software is running properly and that the update system itself is functional. You need to ensure that the client and server can continue to communicate in order to guarantee that you can install future updates and have not break the system. And finally, if any of the actions fails, the system must be able to automatically roll back to the previous known good state. What is Mender? Secure, risk-tolerant, and efficient over-the-air updates for all device software at scale. We do this very well, and we do this at scale. How does it differentiate? What makes Mender different? We're open source with support for varied hardware and all software. We are end-to-end. We provide the client and the server. Supports for customized updating needs. We'll touch base a bit on that today. Support for all kinds of device software. We do, as mentioned, application and OS level, system level updates. We focus on risk management and automated deployments. This is very useful at large scale as you're scaling your devices. And we're also no vendor lock-in. So we support all kinds of infrastructure, all kinds of devices without a specific, essentially, platform that you can, you're locked in. We're just no vendor lock-in. Robustness means primarily that we will never leave a client device in a break state in the field. Redundant root file systems are used to ensure there's no good fallback when bad updates are installed. This also ensures that the updates are atomic, meaning that the component in the system, apart from the update client itself, will never actually see a partially installed update. Integrity checks and appropriate device grouping allow you to ensure that the right OS images are installed on only the required devices, helping you to maintain the overall health of your fleet. By security, we mean using industry best practices. TLS encrypted communications ensures the privacy of the communication channel and keeps the data safe from prying eyes. And then public-private key image signing, as discussed a bit earlier, ensures that even if your server is breached, your devices will not install arbitrary code. The device authentication flow allows you to perfectly control which devices can connect to your fleet management system and allows you to your system to verify that devices are authentic. As mentioned, what do we mean by essentially support for all kinds of software updates? System level updates we define here at Mender would be the doing bootloader, kernel, and root file systems. And done robustly as previous in the discussed in the previous slide. And the definition of an application update can vary depending on the specific user requirements. An example is an application can be a single file, directory, or even a container image. For this reason, it is difficult to enforce one way of deploying application updates. And to support application updates in a generic way, Mender provides what's called update module framework. And using the update module framework, it is also possible to deploy updates to peripheral devices such as microcontrollers and sensors. Customization, it's supported through, this is an alternative, update modules provide an alternative to doing dual root FS updates in Mender called update modules. It's a framework which allows for different types of updating as mentioned. And it's also an extension to Mender client for supporting a new type of software such as package manager, bootloader, or updates for nearby controllers. So we support that through what's called update modules. State scripts allow to control and customize the updating process tailored to your specific needs. Common use cases are user or application confirmation before reboot. In this example on the right, this is common in application which have a UI or that provide critical functionality. Other use cases are enabling and disabling network connectivity before and after checking for an update to reduce bandwidth and other things such as migrate persistent data during a software update. So there are a lot of common cases that one can use state script to customize their updating workflow to their specific needs. At this point, I'll just hand it off to Stephen to talk about some of the case studies. Go ahead, Stephen.
Thank you very much, Farshad. And I'll just remind our audience, if they have any questions they'd like to ask us, they can drop those questions into the Q&A box on the webinar screen, and we'll try and address them at the end. Farshad there explained the technical workflow of over-the-air software updates and how Mender is so elegantly designed to address many of the needs in the workflow. Now this is translating into real business impact. And in last October, we launched Mender Enterprise, and we have several very large enterprises now using Mender Enterprise for their OTA software updating needs. We thought we'd share a sample of these case studies today. To be respectful to our clients, we have anonymized the details and have presented or will present generic case studies. So our first case study on the screen today is a major industrial manufacturer. It's a company specializing in the manufacture of lithium-ion batteries for heavy machinery, often found in remote and hard to reach locations. The company recognized a need for a fully remote-enabled updating system so they could provide new features, fix bugs, and improve the products without changing anything physically in the field. Mender provides reliable OTA updates, atomic updates as the vehicles with the batteries can be disconnected from power sources, so those atomic updates are needed. Mender also fulfills the need to be able to securely update an offline system. So the service team has to be able to use a USB key with a Mender artifact that is securely signed to be able to update a system that has gone offline. Mender provides an API or an interface to provide a new image to a device locally, so there is no need to switch to the developer mode without code signing. This is strategically important from a security control standpoint for the company, because I don't want a situation where somebody could potentially tamper with the device locally. Next slide. Second case study comes from a global heating system company. And again, business context there, the company wants to focus on the core heating system use cases, and they want to find best-in-class technology partners to help them implement the supportive infrastructure. So in this case, Mender doing the updates alongside Microsoft Azure IoT as the IoT platform. So their strategic goals, again, are to deliver secure, highly maintained, and monitored heating products. They want to help their customers to get better control of their systems. And they want to help their network of service companies and large installers to offer much better customer experience in terms of the services they can offer to help their customers manage their heating systems. And of course, they want to find new ways to optimize maintenance times, detect problems, and reduce repair times with those heating systems. Mender is, of course, providing the secure and robust OTA updates with checks, and is doing a very nice and easy integration with Microsoft Azure IoT. And now on to our last case study we're going to show, which comes from a leading global elevator company. Again, the case study here, the business context is to help this company manage the remote configuration and control of the gateways on the elevators in an efficient and robust manner, and also to facilitate first-line support and maintenance of the fleet at the local country level for a support staff that may not have the most advanced technical knowledge when it comes to embedded systems. The goal for Mender in this project is to provide the customer with an update solution with open source at its core, so the customer gets greater control and flexibility of the solution. And of course, providing easy integration into that heterogeneous IoT ecosystem alongside Azure and other solutions the client are using. And of course, to provide role-based access for safer management of the updates to the gateways. And finally, to support end-to-end encryption from the software update to the chip on the hardware, so that the devices, again, can be kept highly secure, tamper-free, and compliant with corporate security standards. And this is where Mender has done specific work with a hardware partner, NXP, to support hardware encryption on the chip. And with that, I think back over to Farshad.
Thank you, Stephen. Here, I just a very quick glance of essentially when you look at Mender and different plans. We talked about the core of Mender, which is the application system, and being able to customize your workflow. That's essentially the open source features that you can use. And then as your OTA requirements increases and use case complexity increases, you want risk management efficiency and more security that propagates along these different plan as you go from left open source to more commercial offerings to the right. What are some of our customers say? Extensive OTA feature set. We're open source, flexible, easy to use, well documented, engaged community, and security and scalability, which is really important and is core to Mender. Some of what we've engaged with in terms of partners and customers. We have NXP, Microsoft, Google, Uber, all partners and customers of Mender. And if you want to learn more, please reach out. Some links here, but you can always find us on mender.io. Thank you very much. And any time for any Q&A, please.
Thank you, Farshad. I think your presentation was so complete and comprehensive that we actually don't have any questions from the audience. But I would like to ask the audience, if you've enjoyed our presentation today, if you find Mender interesting, we'd be delighted to talk to you in more detail about the solution afterwards. So please follow up, send us your questions about OTA software update workflows, and we'd be delighted to assist you. So with that, I think we'll close the session for today.
Thank you so much, Stephen.
Thank you for sharing.
Yes.